Hello student, myself Swapnil Sir and welcome to yet another video on vector chapter. Already we have started lecture series on vector chapter, trigonometric function, determinant matrix and other topic too. So if you are interested to see this video, do check in my playlist. You will get all these videos there. So in my today's video, I'm gonna explain to you all vector chapter with some of the basic concept. Along with we go for some of the previous year questions and important questions from vector chapters. Okay, so in my previous video I explained to you all condition for collinearity, condition for coplanarity. When the two vectors are collinear, how we can apply the condition for collinearity. After that we have learned a section formula, which is for internal division, which is for external division. After that we learn cross product of two vectors, dot product of the two vectors. So all these concepts we have learned in our previous lectures. Now remember, this lecture it is only goes for as the recap of our vector chapter, because as board exam is coming closer, so I'm expecting that we all have to go for only the important topic revision, and along with that some of the important question. Okay, so without further ado, let's get started our today's lecture. First of all, I will explain to you all some basic concept, and then at the end we move for our best important example. Okay, so before I start solving questions, okay, I wanted to explain here the section formula. Okay, vector, dot product, cross product, and condition for coplanarity, condition for collinearity. Okay, so this concept we are going to learn it here. Okay, but our today's lecture mostly based on the section formula, which is from the internal division and which is from the external division. Okay, now we all know that if the two vectors are perpendicular, okay, if the two vectors are perpendicular, we write their dot product is 0. Okay, so now consider that A bar and B bar, these two vectors are perpendicular, we take their dot product 0. Okay, so similar this type of the concept we have to apply in our today's lecture. Okay, now after that we need to know the section formula. Okay, section formula for internal division and external division. Okay, I will just explain this formula in one or two steps here, because this formula needed more time to understand or to explain. Okay, so already I have explained this formula. If you wanted to understand this one, you do check in my playlist. Okay, so section formula for internal division, I will explain to you all first of all for internal division, and then we will move for the external division. Okay, so section formula. Section formula. Okay, first of all we go for the internal division. Internal division. Okay, section formula for internal division. Okay, now that means whenever our triangle or any line segment got the divided by another segment internally, then we say that the section formula for internal division, it is applicable there. Okay, now let me explain with one of the example. Okay, so if I consider this triangle, now see that I consider this triangle here, okay, which is A, B, C. Okay, I consider triangle ABC here. Now consider any other line segment which divides the triangle ABC at a point D. Okay, okay, so the line segment BC, it got divided by D as a internally. Now we can see that this segment, line segment which divided by point D in the internally. Okay, now if it divide in through the internal way, then it is having some of the ratios of its dividation. Okay, so I consider that ratio as a m as to n. Okay, that means line segment BC which divided by point D divided by point D in the ratio of m as to n. Okay, that means whenever we have such a condition in our example, that time we have to apply the section formula for internal division. Okay, now see that in our vector chapter, with every vertices we will get the position vector exists there. Okay, so now with the vertices A, consider A bar, it is a position vector exists there. Okay, with the vertices B, consider B bar position vector. With the vertices D, we have position vector D bar, and with the vertices C, we have position vector C bar. Okay, Now see that what is the section formula for internal division. It says that when we take this ratio from the other side here, into its opposite position vector c bar, okay, that means first constant into c bar, okay, plus it is for the internal division, so we are taking positive sign there, n into opposite vector b bar, okay, n into b bar divided by plus n, which is equal to d bar, okay. So we consider this one as a section formula for internal division, okay. So in our subsequent example, we can apply these results in our coming examples, okay. Okay, now let's go for the next section formula for external division. Okay, I will change the color for external division, okay. External section formula for external division, okay. So what the section formula for external division, it says that if any line segment or any our triangle or any other closed figure that divided by our another line segment externally, that means it divides our line segment externally, then we say that section formula for external division can be applicable. Now let me explain with one of the figure, okay. So we go for visualization how it externally divides, okay. So for that, consider any obtuse angle triangle, okay. So I consider here obtuse angle triangle. Now let's see that. So this one is our obtuse angle triangle, okay. Okay, as we don't have space here, so I taken this one, okay. So this one is our obtuse angle triangle A, B and C, okay. Our obtuse angle triangle ABC, it is here, okay. Now this obtuse angle triangle, we can see that on another point I have taken here, point D, okay. So that point D, which divided line segment BC at externally, okay. The line BC, line segment BC, which divided by point D, but that point it is from outside of our triangle, so we consider it as the external division of our triangle by using point D, okay. Now see that if we have vertices, so if and we are learning under vector chapter, okay. So every vertices, like A is having position vector A bar, C is having position vector C bar, B is having position vector B bar, and D, which is having position vector D bar, okay. And now if the D bar which divides like line segment BC at externally, that means there exists some ratio of a division, okay, the ratio of a division of that line segment. So consider this ratio as a m as to n, okay. So and m and n both are scalar here, that we are taking it from the real number, okay. Yes, so m and n are scalar here. Now what we do, we go for the first that m scalar into the position vector C bar, n scalar into position vector D bar divided by m minus n, okay. Now see that we can write this one as position vector for external division, okay. Now see that n into D bar minus m into C bar divided by n minus m, okay, n minus m. So if you are taking n minus m, then denominator has to be n minus m, okay. So this one is our section formula for external division, okay. And condition for collinearity also you need to know, okay. When we say that the two lines are collinear, okay, the collinear means we have the line which are the parallel to each other or which are the along line to each other, okay. Along line means, now see that line segment AB, which along with the line segment B into B dash, okay. Now see that line segment AB along with the line segment B dash, okay. That means both are the along lines. So that means we consider these are the collinear lines, okay. Now one more condition we have here for collinear line. If I do have the two lines here, A, B and B, B dash, okay. I consider here two lines A, B and B, B dash, okay. Now these both lines are parallel to each other, okay. And if these lines are parallel, then we consider them as a collinear line. Okay, that means one line can be written as some scalar multiple of another line, then we consider this line as the collinear line. Okay, for the coplanarity of a line, we need to know that coplanarity means the line which come under single plane. Okay, and for finding the coplanarity of the line, so we need to go through some direction ratios of the line, direction cosines of the line. Okay, so that I will explain while examples are coming. Okay, while examples are there, because if I'm going to explain this one here right now, it is difficult to understand. Okay, so I will explain this topic while our questions. Okay, while our question solving. Okay, now let's move for the questions from our board exam. First question, it asked in February 2020 board exam for 4 marks. Okay, and question it says that in a triangle ABC, okay, in a triangle ABC, angle B, which is a right angle triangle. Okay, that means we have given triangle ABC, which is a right angle triangle. Okay, so what we have here, triangle ABC. Okay, triangle ABC, how that triangle is, which is a right angle triangle. Okay, a right angle triangle. Okay, so we have given triangle ABC is a right angle triangle, but at what point? At point angle B, point B. Okay, so that means angle B, which is given pi by 2, that means we write it as the 90 degree. Okay, that means angle B, which is given 90 degree. Okay, and angle A and C, which is less than 90 degree. Okay, so and vertex is also given, where vertex is A vertex is given 5, 6, 4, 5, 6, 4. Okay, vertex is A given 5, 6, 4. After that, vertex is B is given 4, 4, 1. I'm writing what we have given here. And vertex is C, it says that 8, 2x, 8, 2, x. Okay, so we have 3 vertices A, B and C, and at vertices B we have right angle triangle. Now let me draw the triangle. Then you can understand it easily. Okay, and now see that we have triangle ABC, that means and angle B need to be a right angle triangle. Okay, that means from where point A coming to the B, which is a perpendicular to B. Okay, now see that, let me draw the triangle. So here I drew one triangle here. Yes, triangle A at vertices A, again angle vertices B and vertices C here. Okay, so I drew this triangle in such a way that angle B needs to be a 90 degree, or which is a pi by 2. Okay, 90 degree or pi by 2. And if it is a right angle triangle, obviously angle A and angle C, which need to less than 90 degree. Okay, yes, so we have angle B which is a 90 degree, and let me plot the vertices. A vertices C there 5, 6, 4. So it is a 5, 6, 4. Vertices A 5, 6, 4. B 4, 4, 1, 4, 4, 1. Okay, and vertices C 8 to x, 8, 2, x. We have 3 vertices given here. Okay, and we want the value for x. What we want here, now always remember what we need to find. Okay, and follow the direction what we want. We want here the value for x here. Okay, so we want the value for x. Now one more condition I wanted to explain here. If the two vectors are perpendicular, okay, if the two vectors are perpendicular, then we write their dot product is 0. Okay, that means A is perpendicular to B. Okay, vector A bar, which is a perpendicular to vector B bar, that means we write it as the vector A bar dot vector B bar, which is equal to 0. Okay, the dot product of these two vectors needs to be 0. Okay, now see that AB, vector AB, which is a perpendicular to the vector BC. Okay, vector EB, it seems like that vector EB, which is a perpendicular to vector BC. Okay, that means given vector AB bar, which is a perpendicular to vector BC bar. Okay, Now it is obvious here in our right angle triangle, if one angle it gives us a 90 degree, that means the corresponding sides of this triangle which are the 90 degree. Okay, that means vector AB bar which is a perpendicular to the vector BC bar. Okay, both are the perpendicular to each other. Now see that we want the value for AB bar and BC bar here. Okay, and that means two vectors are perpendicular. That means vector AB bar, when we multiply to vector BC bar, we will get their dot product is 0. Okay, we will get their dot product 0. Now using this condition, we easily can define the value for x. Okay, now let's move for finding the value of x. Okay, now first of all we want the value for AB bar. So if you wanted to show the dot product of these two vectors are 0, that means first of all find out these two vectors first. Okay, and then proceed for their dot product. Okay, so we want the value for AB bar. Okay, let's move for the finding the value of AB bar. Okay, I want the value for AB bar. Okay, okay, so we know that position vector AB bar can be written as vector AB bar can be written as B bar minus A bar. Okay, vector AB bar can be written as B bar minus A bar. Now you all are asking that where from that B bar and A bar coming for finding the vector AB bar. Okay, I will explain here. Now see that every vertices there exists a position vector. Okay, now see that our vertices A which having position vector A bar. Okay, so for vector A, now let me first of all write the position vector for A, B and C. Okay, so I'm gonna write this here, A bar, position vector A bar using vertices A. Okay, need to introduce only the coefficient of I, J, K while we are taking the position vectors. Okay, so 5 times I plus 6 times J plus 4 times K. Okay, which is the first position vector, which is 5 times I plus 6 times J plus 4 times K. Okay, they are the vectors, so take the cap for I, J, K. Okay, so I got the position vector A bar. Similarly go for the position vector B bar. Okay, so 4 I cap plus 4 J cap plus K cap. Okay, 4 I cap plus 4 times J cap plus K cap. Okay, so this one is a position vector B bar. Okay, 4 I cap plus 4 J cap plus K cap. Now position vector C bar, let's me define C bar, 8 times I cap plus 2 times J cap plus X times K cap. Okay, that means 8 times I cap plus 2 times J cap plus X times K cap. Okay, so now see that I have here 3 of these position vector. Okay, using this position vector we will define, okay, this one is a first, this one is a second, and this one is a third. Okay, using 3 of these position vector we go for finding the vector AB bar. Okay, now vector AB bar, it says that B bar minus A bar. Now substitute the value for B bar, so 4 I cap plus 4 J cap plus K cap. Okay, 4 times I cap plus 4 times J cap plus K cap. Okay, this one is our first position vector B bar. Okay, now which takes we have to subtract this one from the A bar. Okay, and negative of A bar means negative of 5 I cap, negative of 6 J cap, negative of 4 K cap. So what I have done, basically I multiplied negative sign under the bracket. Okay, so negative of 5 I cap, I'm directly writing the negative side inside this vector A bar. Okay, so negative of 5 I cap, negative of 6 J cap, and negative of 4 K cap. Okay, negative of 5 I cap, negative of 6 J cap, negative of 4 into K cap. Okay, so this one is the vector AB bar. Okay, and now go for the subtraction of a similar coefficient of I, J and K. Okay, and now so 4 I cap minus 5 I cap. Okay, that means we will get the negative of I cap. Okay, negative of I cap, 4 I cap minus 5 I cap, negative I cap, plus 4 J cap minus 6 J cap, we get the negative of 2 times J cap. Okay, plus K cap minus 4 K cap. Okay, that means negative of 3 times K cap. Okay, now see that 1 times k cap minus 4 times k cap. Okay, 1 times k cap minus 4 times k cap. So we'll get the negative of 3 k cap. Okay, so it is the vector a b bar. Okay, so I found the vector a b bar. Okay, so I got the first vector which is the a b bar. Let me underline here. Okay, a b bar. So similarly, go for finding the vector bc bar. Okay, so I found the vector eb bar. Similarly, I want the vector bc bar. Okay, so bc bar, vector bc bar can be written as position vector c bar minus position vector b bar. Okay, so position vector c bar minus position vector b bar. Okay, so bc vector bc bar can be written as position vector c bar minus position vector b bar. Okay, now substitute the value for position vector c bar. So position vector c bar, we have here 8 I cap plus 2 j cap plus x k cap. Okay, 8 I cap plus 2 times j cap, okay, plus x times k cap. Okay, yes, now we have to subtract minus b bar. So minus 4 I cap minus 4 j cap minus k cap. Okay, minus 4 times I cap minus 4 times j cap minus k cap. Okay, so what I have done here, I have multiplied the negative sign to the vector b bar. Okay, position vector b bar. So negative into positive 4 I cap means negative 4 I cap. Similarly, negative 4 j cap and negative k cap are these are the three position vectors. Okay, now go for finding the vector bc bar. So vector bc bar can be written as 8 I cap minus 4 I cap. Okay, so 8 times I cap minus 4 times I cap, we get the 4 times I cap. Okay, plus 2 j cap minus 4 j cap, that means we get the minus 2 times j cap. Okay, that means 2 times j cap minus 4 times j cap. Okay, so it goes to the negative 2 times j cap. Okay, so plus x cap minus x cap. Okay, x times k cap minus 1 times k cap. Okay, so we cannot subtract, x is a variable here that we want the value. Okay, that means we write plus x minus 1 into, take k cap common from here. Okay, x minus 1 into k cap. Okay, now see that I got the next position, next vector here, vector bc bar. Okay, which is a 4 times I cap minus 2 times j cap plus x minus 1 into k cap. Okay, now as we have this condition, vector ab bar into vector bc bar, which is equal to 0, because these two vectors are perpendicular to each other. Okay, so if these two vectors perpendicular, then we write their dot product, which is equal to 0. Now let me write their dot product here. Okay, so we write a b bar dot bc bar, which is equal to 0. Now substitute the value for ab bar. Okay, ab bar, which is here, minus I cap minus 2 j cap minus 3 k cap. Okay, minus I cap minus 2 times j cap minus 3 times k cap. Okay, minus I cap minus 2 j cap minus 3 k cap, which multiplied by 4 I cap minus 2 j cap minus 2 times j cap plus x minus 1 into k cap. Okay, okay, which is equal to 0. Okay, so what I have done, I multiplied these two vectors. Okay, ab bar dot bc bar, so I got their dot product is 0, as these vectors are perpendicular to each other. Okay, yes, now what we have here, we have to multiply minus I cap minus 2 j cap minus 3 k cap to the vector 4 I cap minus 2 j cap plus x minus 1 into k cap. Okay, now go for the similar I cap into I cap as a vector. We know that I cap into I cap gives us the value 1, j cap into j cap gives us the value 1, and k cap into k cap, which gives us the value 1. Okay, okay, now if you go through the multiplication of I cap into j cap, it always 0. Okay, that means let me write here I cap into I cap. Okay, I cap into I cap, which is the value 1. Okay, and that means I cap into I cap 1 means j cap into j cap also goes to 1, and similarly like a k cap into k cap, it also goes to 1. Okay, and the remaining part here, I cap j cap into I cap, okay, j cap into I cap or I cap into j cap, which goes to the 0, okay. These other coincide variables are goes to 0, okay. Now use this condition for finding the multiplication, okay. So negative I cap plus 4 times I cap, so negative 1 into plus 4, okay, into I cap, that means it goes to 1. So it doesn't matter that we have to write that I cap into I cap, it is the I square, okay, no need to write 1. Okay, so let's go for the next. Yes, negative 2j cap minus negative 2j cap, so we get the positive 4 times j cap, okay. So negative 2 multiplied by negative 2, we will get the positive 4, okay. So negative, negative, positive, j cap into j cap, it goes to the 1. Similarly, negative 3 into x minus 1, so negative 3 under bracket x minus 1, okay, and k cap into k cap, it goes to the 1, okay. That means I have here the value negative 4 plus 4, okay, minus 3x plus 3, which is equal to 0, okay. Negative 4, positive 4, we can cancel this one. So we get the negative times 3x, which is equal to negative of 3, okay. So what I have done, I written negative 3x as it is, and that positive 3 I taken to the other side. So I got the negative 3x, which is equal to negative 3. So 3x, which is equal to 3, and x, which is equal to 3 divided by 3, okay. So I got the value for x, which is equal to 1, which is our required answer, okay. Now see that how easy solution is this, okay. Just need to apply some of the basic concepts, okay. Like I have taken the dot product for two perpendicular vectors, and then I defined the their value of x, okay. I'm expecting you all have understood this solution, okay. Let's move for the next example. In our next example, we have to show that the points are collinear, okay. Now it comes again the condition for collinearity, okay. Already as earlier I have explained the condition for collinearity, okay. If the two vectors are collinear, that means we write one vector is some scalar multiple of another vector, okay. That means we write these two vectors are collinear, okay. This one is the condition for collinearity. Now let me explain here the condition for collinearity, okay. Yes. Now see that I do have position vector a bar and position vector b bar, okay. These two vectors are collinear. I just consider here, okay, that consider just for your understanding. So position vector a bar is collinear to b bar, okay. Position vector a bar, which is a collinear to position vector b bar, then we write first, that means the first position vector, which is some scalar multiple of a second position vector, okay. That means t, I consider here what is the value for t, which is a scalar, okay. And a scalar means we can take any of the constant here, okay, as a scalar, okay. Now see that here we have two position vector and they are the collinear, okay. Then that means we write one of the position vector can be written as some scalar multiple of another position vector, okay. Now first of all define the vertices first, okay. Define these vertices, okay. Now I have here point, I have here points, okay. So what points we have here? Point A, vertices A 4, 5, 2, vertices A given 4, 5, 2, vertices B it is also given, okay, 3, 2, 4, okay. Vertices B given 3 to 4, and C also given, vertices C is given 5 times 5, 8 and 0, okay. That means if we have 3 vertices given, that means there exists every vertices there exists one single position vector, okay. And that I'm going to write the position vector vertices for position vector. Now see that A 4, 5, 2, it is the single vertices. So at the place of vertices we do have position vector. Now consider that position vector is a small a bar, okay. So I consider this small a bar as a position vector, and write this position vector in the form of I cap, j cap, k cap, okay. So this one is the standard form for writing position vectors, okay. Yes. Now first coordinate for our x we define it in the form of I cap, second in the form of j, and third in the form of k. Okay, so position vector a bar can be written as 4 times I cap plus 5 times j cap plus 2 times k cap. Okay, this is our position vector a bar. Similarly, define the position vector b bar, 3 times I cap plus 2 times j cap plus 4 times k cap. Okay, this is the second position vector b bar. Position vector c bar can be written as 5 times I cap plus 8 times j cap. Okay, I'm taking that I cap because it's the position vector having direction as well as magnitude. Okay, that's why I'm taking there as a cap. Okay, so 5 I cap plus 8 j cap plus 0 times k cap. Okay, 0 times position vector k cap. Now see that I do have 3 position vector, and I have to show that the points A, B, C are collinear. Okay, that means line AB, which is parallel to line BC, whether we have to show line AB parallel to BC, or we have to show AB line which is along with the line BC. Okay, that means which type of the condition we have to prove here. So see that line AB, I do have line AB which is along with the line BC. Okay, so this one is the condition for collinearity. So we write AB, vector AB, which is along with the vector BC, or one more condition we can write here, vector AB which is a parallel to vector BC. Okay, that means one of the condition we have to prove here. Okay, this is one of the conditions. So this one is the first, this one is the second condition. Okay, so we have to prove that whether two lines are parallel or these two lines are along. Okay, along lines. Now let's go for proving these two lines are parallel. That means we have to show vector AB and vector BC are some scalar multiple of each other, as I have explained here. Okay, so that one we have to prove here. Okay, now let's move for the solution. So I want the vector AB. Okay, I want the vector AB. So vector AB bar can be written as a position vector B bar minus position vector A bar. Okay, so position vector B bar minus position vector A bar. Okay, now we do have the value for position vector B bar. Substitute here 3 times I cap, okay, plus 2 times j cap plus 4 times k cap. Okay, this one is our first position vector, 3 I cap plus 2 j cap plus 4 k cap, minus position vector A bar minus 4 I cap minus 5 j cap minus 2 k cap. Okay, minus 4 I cap minus 5 j cap minus 2 times k cap. Okay, we have position vector B bar minus A bar. Okay, so that means we write 3 I cap minus 4 I cap. Okay, 3 I cap. Now subtract similar I cap, j cap and k cap. Okay, so 3 I cap minus 4 I cap, we can write it as the minus times I cap. Okay, because 3 minus 4 which gives us -1, and -1 into I cap. Okay, so 2 j cap minus 5 j cap, 2 j cap minus 5 j cap minus 3 times j cap, we write this one, plus 4 k cap minus 2 k cap, we write it as the 2 times plus 2 times k cap. Okay, so this is the value for position vector AB bar. Okay, this one is our required position vector AB bar. Okay, need to be. Okay, now let's go for the next position vector. We have to show the position vector BC bar. We have to find out the position vector BC bar. So we can write position vector BC bar as a, vector BC bar as a position vector C bar minus B bar. Okay, now substitute the value for C bar and B bar. Okay, the value for C bar, 5 I cap plus 8 j cap plus 0 k cap. Okay, so 5 times I cap plus 8 times j cap plus 0 times k cap. Okay, so this is the value for C bar. Okay, vector position vector C bar minus of a position vector B bar. Okay, so multiply negative sign to the position vector B bar and directly go for substitution. Okay, negative 3 I cap, negative 2 j cap, negative 4 k cap. Okay, negative times 3 I cap, negative times 2 j cap, negative times 4 k cap. Okay, So we have negative 3 I cap, negative 2 j cap, negative 4 k cap. Okay, go for similar coefficient subtraction. Okay, so 5 I cap minus 3 I cap. So we write it as the 2 times I cap. Okay, after that 8 j cap minus 2 j cap, we can write it as the plus 6 times j cap. Okay, plus 0 times k cap minus 4 k cap, we can write it as the minus 4 times k cap. Okay, this is the value for position vector bc bar. Okay, so I found the value for position vector ab bar and position vector bc bar here. Okay, these two position vector we have here. Okay, now let's move for next part. Okay, so when we have two position vectors, okay, when we have two position vector, when we have two vectors which are the parallel or collinear or along lines, okay, then we write their dot product is a 0. Okay, that means we write ab bar dot bc bar, ab bar dot bc bar, which is equal to 0. Okay, we write their dot product ab bar into bc bar, which is equal to 0. Okay, now put that ab bar dot bc bar, let's find it out whether it goes to 0 or not. Okay, so ab bar, which is a it's not a 0, because we write their dot product as a one vector which is a scalar multiple of another. Okay, so we write one vector which is some scalar multiple of another. So that's we have to define here. Okay, so ab bar, we know that minus I cap minus 3j cap plus 2k cap. Okay, so what we do, take a negative common from this one here, bc bar. Okay, so if I take a negative common here, negative 2 common from this vector bc bar, so which gives negative 2 times I cap, negative 2 times negative I cap. Okay, negative 3 times j cap, negative means positive 2 times k cap. Okay, positive 2k cap. Okay, now we can see that negative I cap, negative 3j cap, negative plus 2k cap, it is under bracket here, and which is some scalar which is we have here negative upper 2. Okay, so we can write ab bar in some scalar multiple of bc bar. Okay, so ab bar we can write some scalar multiple of bc bar. Okay, that means put the value for ab bar here, minus I cap minus 3 times j cap. Okay, minus I cap minus 3j cap plus 2k cap. Okay, is a some scalar multiple, okay, which is a negative 2 into minus I cap minus 3j cap plus 2k cap. Okay, minus I cap minus 3j cap j cap plus 2 times k cap. Okay, so we can see that first position vector ab bar can be written as some scalar multiple of another position vector. Okay, and that is scalar t, we write that scalar is a negative upper 2. Okay, and if we can define one scalar which is some scalar multiple of some scalar multiple of another vector, so then we write these two lines are parallel or these two lines are along lines. Okay, and if the two lines are parallel or along line, then we say that vector a bar, vertices a bar, vertices b bar and vertices c bar, these three are the collinear vertices. Okay, so I hope you all have understood this solution. Nothing is difficult here. Okay, so let's move for the next example. I'm expecting that you all have understood. Let's move for the next. So we have given find the value of a c which is satisfy modulus of a c into u bar which is equal to 3. Okay, and a u bar which define here I cap plus 2j cap plus 3 times k cap. Okay, so which is question from latest question, which is from March 2023 board exam. Okay, and it asks for 4 marks. Answer it is only in a 3 to 4 steps. Okay, we don't have anything there. Okay, what we want here, we have to find the value for c here. Okay, and given conditions, modulus of a c into u, okay, modulus of a c into vector u bar which is equal to 3 given. Okay, and here vector u bar can be written as I cap plus 2 times j cap plus 3 times k cap. Okay, this one is a vector u bar given. Okay, and we have to find out the value for constant c. Okay, Now see that we don't have any other concept, so we are going to directly find the value for modulus of vector. Okay, so for finding the modulus of any vector, we know that we take under square root of a coefficient square. Okay, under square root coefficient of our vector and their squares. Okay, we take as their modulus. Okay, so what we do here, first of all, we go for finding the modulus of u bar. Okay, so modulus of u bar can be written as under square root, okay, I cap plus 2j cap plus 3k cap. Okay, the square for modulus of I cap. Okay, modulus of I cap means first coefficient, it's a square, that means 1 square plus second coefficient square, that means 2 square plus third coefficient its square means 3 square. Okay, so we'll get the modulus of u bar. Okay, so modulus of u bar can be written as 1 plus 2 square, it written as 4 plus 3 square as a 9. Okay, so we can write here modulus of a u bar, which is equal to square root of 14. Okay, okay, square root of 14, which is not a perfect square for any number, so keep that one as it is. We do not want the answer in a fraction format. Okay, so keep that as it is. So I got the modulus of u bar. Okay, and we have given modulus of c into u bar, which is equal to 3. Okay, modulus of c into u bar can be written as modulus of c into modulus of u bar. Okay, modulus of c into modulus of u bar, which is equal to 3. Now what we do, we substitute the value here, modulus of c into modulus of u bar here. Okay, just need to substitute the value, don't have any more calculations. Answers are there in 3 to 4 steps. So we know that modulus of c into u bar, which is equal to 3. Okay, so modulus of c into u bar can be written as modulus of c into modulus of u bar. Okay, which is equal to 3. As both are the modulus quantity, that means it represent all the values are positives. Okay, yes, so keep modulus of c as it is, as we don't have the value for modulus of c, because we want the value for modulus of c. Okay, and modulus function always represent whenever any negative or positive term goes inside that modulus, it gives us the positive value. Okay, remember this one. Okay, modulus of c, which is equal to 3 divided by modulus of u bar. Okay, so I can write modulus of c as a 3 divided by modulus of u bar. Okay, yes. Okay, so 3 divided by modulus of u bar, and we know that modulus of u bar, which is equal to 14. So modulus of c can be written as c divided by square root of 14. Okay, 3 divided by modulus of square root of 14. Okay, as we have modulus of u bar, which is equal to square root of 14, and we know that we want the value for only c. Okay, what we want the value for only c, not a modulus of a c. Okay, so what is the difference between c and modulus of a c? This thing you all need to know here. Okay, difference between c and modulus of a c. Okay, these two terms are not the same, keep this thing in mind. C and modulus of c, these are the two different terms. Modulus gives us positive and negative signs, and only c represent it is having positive sign. Okay, that means modulus of a c can be written as plus minus of a c. Okay, now if you want take any positive value under modulus, it goes to the positive. Negative value under this modulus, it goes to the positive. Okay, that means we write c, which is equal to plus minus of 3 divided by root of 14. Okay, this one is our required answer. Okay, what we have answer final, c divided by, let me write it again, c, which is equal to 3 plus minus 3 divided by square root of 14. Okay, this one is our value for c. Okay, we want the value for c, not a modulus of a c. So I hope you all have understood this solution. Answer there is just only one step, that we need to know how to find out the modulus for any vector. Okay, so first of all I found here the modulus, and then I substitute all these values in our modulus of a c into u bar. Okay, now let's move for the next question. Very easy type of the questions. Okay, now see that we have given vector vertices a bar, b bar, and c bar are the vertices of a triangle ABC. Okay, So we have given 3 vertices A, B, C with their position vector A bar, B bar and C bar. Okay. Now let's define the vertices A bar, comma, B bar and capital C bar. Okay. C bar. Okay. These are the vertices. Are the vertices of triangle ABC. Okay. Are the vertices of a triangle ABC. Okay. Okay, let me write it again. Triangle ABC of triangle ABC. Okay, these 3 are the vertices of a triangle ABC. Now what we do, first of all, we go for plotting the figure. Okay, once you come to understand visualization of that given data, then subsequent part, it's quite easier. Okay, that you can define the answer in just 2 to 3 steps only. That just we get the feel only when the figures are coming in front of us. Okay, now let me plot the figure first here. Okay. Okay, so we have to plot the figure first. Here we have 3 vertices. Let's consider these 3 vertices here. Okay, so I am going to draw this figure here. So we can see that one here. So consider this one is a triangle, as these 2 lines are not look like a triangle. Okay, just let me draw this again. Okay, so let me plot by my hand only. Okay, so this one is the first line of our triangle. Okay, so consider this one is the vertices here. Okay, I drew this triangle over here. I was okay, so this one is our, okay, this one is how here A of A bar, which is the first position vertices here. Okay, then B of B bar and C of C bar here. Okay, so which is a B of a B bar and a capital C of a C bar here. Okay, A bar, B bar, C bar, which represent position vector. Okay, and we have here G bar as a centroid. Okay, centroid as a G bar as a centroid. That means the middle point centroid, it is coming here. Okay, yes, so we can draw this one is the median. Okay, this one is our median for triangle. Okay, this one is our the median of our triangle. So we have to represent the centroid. That means we have to take the angle bisector from every triangle of a triangle. Okay, angle bisector. So I have taken angle bisector from A of A bar. Similarly, angle bisector from B of B bar and angle bisector from C of C bar. Okay, I have taken 3 of these are angle bisectors. Okay, now and the point which is coming here, the center point, we consider as the centroid. We consider it as the centroid of our triangle. Okay, and write this one is a G of G bar. Okay, so we have given G of G bar is a centroid. So consider G of G bar. Okay, what we have given more, centroid. Centroid as a G of G bar. Okay, we have given centroid G of G bar. Okay, and we have to prove that centroid G of G bar is having a position vector G bar as a, what we have to prove, position vector G bar as a bar, position vector A bar plus position vector B bar plus position vector C bar divided by 3. Okay, this condition we have to prove it here. Okay, now if we know that the centroid which divides, okay, let me write it as the third point, capital D of D bar here. Okay, another point D of a D bar here, and centroid I written G of a G bar here. Okay, now see that if they are dividing centroid, that means above first, if the downside part of our centroid, if it is having 1, then upside part of that centroid, it goes to the 2 times 1. Okay, that means if I consider downside part is x, then upper part it goes to the 2 times x. Okay, that means this is the division, internal division of our triangle, okay, internal division of our angle bisector of a triangle, because this one is a standard property. If our downside part is the x times, then upper part it goes to the 2 times x, okay. So you may consider any value for x. So as our better calculation, I consider here 1 and 2, okay. So downside part 1 here, upper part here 2, okay. Now as we can see here, it seems like that d of d bar is the midpoint, okay. What we have here, d of d bar is the midpoint, but where it is the midpoint? It is the midpoint b of b bar plus c of b bar, c bar, okay. Midpoint of b of b bar and c of c bar, okay. C of c bar. Now we know that if any vector or any position vector divide line segment at a midpoint, okay, then we write the addition for first position vector plus second position vector divided by 2 as the midpoint of a d bar, okay. So we can write the midpoint of a d bar as a position vector b bar plus position vector c bar, position vector b bar plus position vector c bar divided by 2, okay. This one is our midpoint of our base b bar, okay, and c bar, position vector b bar c bar. Now so we have the value for d bar which is equal to b bar plus c bar divided by 2. And one more condition, as we can see that our angle bisector of a triangle which is a of a bar to d of d bar, okay, it divides our triangle internally, okay, it divides our triangle internally. Then we can easily use internal division formula from the section, okay. So we use here section formula for internal division, okay, by using, let me write, by using section formula. Why we have to use internal division section formula? Because our line segment or our angle bisector of our triangle which divides our triangle internally, okay. So if somehow if it divides triangle externally, then we have to move for the external division, okay. Now let's go for the section formula for internal division, okay. What we do, we have the ratio 2 as to 1, that means we take opposite ratio for their vertices, okay. That means 2 times a position vector d bar, we can write g bar as, okay, we can write g bar as, that is the centroid g of g bar as 2 times d bar, 2 times d bar, 2 times position vector d bar plus 1 times position vector a bar, okay, 1 times position vector a bar divided by 2 plus 1, okay. That means m a bar plus n b bar upon m plus n as the position vector, okay. We can write this one as, we know that the section formula m a bar plus n b bar upon m plus n as the position vector, okay. So we are this, sorry, which is the internal division formula, okay. So that one we are going to apply here. So I applied this formula here. So we got the g bar which is equal to 2 times d bar plus 1 times a bar upon 2 plus 1, okay. So the value for d bar already I have defined here, okay. So substitute this value here, okay. Put the value here for d bar, okay. So we write g bar, position vector g bar can be written as 2 times d bar, which is a b bar plus c bar divided by 2, okay. So why I have changed color here? Because this step it is new here, because you need to understand this step here, okay. That's why I changed the color. 2 times d bar plus a bar, okay, upon 2 plus 1, that means I'm going to write it as the directly 3. Now see that 2 here cancel them. So we get the g bar which is equal to a bar plus b bar plus c bar divided by 3 as a centroid for our triangle. Now see that answers are there in only 3 to 4 steps. We just have to apply some of the basic concepts here, okay. So what I have applied here, I applied the section formula and midpoint formula for finding the centroid of our triangle, okay. This is the standard proof for the centroid of a triangle in our vector, okay, with respect to vector. Now let's move for the next question. I hope you all have understood this one, okay. This one, two more questions are still there. Yes. Now next question, I have taken a of a bar, b of b bar be any 2 points in the space, and P of P bar be the line segment EB dividing the lines which is internally as the m as to n, then P bar can be written as mb bar plus na bar upon m plus n. Okay. Yes, now what we do, first of all we go for plotting the figure here. Okay, now see that question which is very much important, asked in board exam multiple times. Now see that question asked in March 1998, March 2001, March 2006, March 2015, March 2019, March 2022, and October 96, 97, and October 2004. Okay, very much important question. Okay, as I can't found this question in my previous question paper like a 22, 23. So we do have possible chances for upcoming exam. Okay, for this question. Okay, so go with the proper preparation, and this type of the question makes you score higher in your board exam. So don't forget to solve this question first. Okay. Yes. Now let's write. Let's draw the figure that we have given in our question. Okay, A of A bar, B of B bar, C of C bar are the vertices given. Okay. Now let's plot the figure. So we have triangle like this. Okay. So I have written. Let me. I don't know. My hands are not coming. Okay. So I have taken. So I have this base of our triangle. I consider here. Okay. So let's plot the triangle here. Okay, I have a triangle. I drew it here. Okay, so I have I drew that triangle because just wanted to show the internal line segment. How can it divides our given line segment? Okay, just for take it these two lines for just for understanding. Okay. Okay, write down vector A, vertex A, vertices B we have here. Okay. Yes. And consider this is a vertices O, because as we don't have the vertices C, so I consider here vertices O here. Okay. Consider this line as the internal bisector for our line segment. Okay, or internal bisector of our triangle. Okay. So AB, and we are define here internal division. Okay, with what ratio that lines divides internally. Okay, so consider this ratio M as to N as an internal ratio. Consider this vertices as a P. Okay, so this one is the internal division for our line segment AB. Okay, this one is the internal division for our line segment AB. So this one is a vector position vector A bar, this one is a position vector B bar, and this one is a position vector P bar. Okay, at every vertices we have the position vector. Okay, the vertices B bar which is having position vector B bar, vertices A bar having position vector A bar. Okay. Yes. So what we do here, this line segment goes to this direction. Okay, this direction. You need to know the direction because we are going to apply we are going to apply vector addition for triangle. Okay, angle of a triangles. So that one we are going to apply here for finding the proof of our theorem. Okay. Okay, now let's move for the what we have given in our theorem. A of A bar, B of B bar, any 2 points in a space. Okay, let me change the color. Okay, so we have given A of A bar and B of B bar, B any 2 points. Okay, B any 2 points in a space. Okay, we have given A of A bar, B of B bar, be any 2 points in a space, and P of P bar be a point on a line segment AB. Okay, so P of P bar we have point in a line segment AB. So P of P bar here we point. Okay, P of P bar be a point on a line segment. Okay, on a line segment AB. Okay, P of P bar be a point on a line segment AB. Okay, dividing internally in the ratio. Okay, given dividing internally m as to n. Okay, internally m as to n, and then we have to prove here what we have claimed here. we have to prove here P bar, which is equal to m into A bar plus n into B bar upon m plus n. Okay, this is our final claim of our statement. Okay, now see that these all things are given in our statement of theorem. Okay, that one you have to first of all understand. Okay, what we have given in our statement. So define it in our triangle, write it in your page, then you come to understand what we have given. Okay, and then subsequent part, I don't think so anything it is difficult, just need to apply one or two basic concept, directly you will get the final proof. Okay, so this one is a standard theorem section formula for internal division. What is this formula? This is the section formula for internal division. Okay, section formula. Section formula. Okay, this one is a section formula. Okay, so as we have positive sign defined there, that means which represents section formula for internal division. Okay, so this one is a section formula for internal division. Let's go for the next steps. Okay, so first of all define what we have in our here. Okay, okay, we can write their ratios of the lines. Okay, ratios of the line segment. So observe this triangle carefully. Okay, so it seems like that our triangles having P as a midpoint for line segment AB, and which divides that line segment AB in the ratio as a m as to n. Okay, and we have line angle bisector P bar, it is also there. Position vector A bar, B bar also defined over here. Okay, okay, so we can see that the ratios for AP as to PB given. Okay, what we have given? Ratio. Okay, what we have given? Ratio AP divided by PB. Okay, so what is the ratio for AP divided by PB? So AP divided by PB, which is a m divided by n. Okay, this is the ratio which we have given in our triangle, that we need we know only these things. Okay, go for the calculation using these ratios. Take that n to the other side, PB to the other side, you will get the n multiplied by AB, which is equal to m multiplied by PB. Okay, this one is our second vertices. Okay, so n multiplied by AB, which is equal to m multiplied by PB. Okay, so now AB position vector, sorry, vector AB can be written as, now see that vector AB, let me change the, okay, so AP multiplied by PB is there. Okay, AP, it is AP, not a AB. Okay, so we write AP. Okay, AP and PB, they are in the ratios of the m as to n. Okay, so AP is here and AP here. Okay, so AP divided by PB, which is equal to m divided by n. Okay, that means AP divided by PB, which is equal to m divided by n. So n multiplied by AP and m multiplied by PB. So I have multiplied n into m to the other sides. Okay, so I got this value here. Okay, so AP can be written as, okay, AP can be written as by using a vector addition of our sides of the triangle. Okay, so AP can be written as AO plus OP. Okay, AP can be written as AO plus OP. N into AP can be written as AO plus OP. So what I have done, I applied vector additions of the sides of our triangle. Okay, vector addition for sides of the triangle. So again, m multiplied by PB. Okay, now see that PB can be written as PO plus OB. Okay, PO plus OB. Okay, PO plus OB. So AO plus OP I have written here as a AP. Okay, AP can be written as AO plus OB, which is a vector law of vector addition of our triangle. Okay, so we write this as a, okay, n keep as it is, positive OP also keep as it is AO. Now see that if we go through from point A to point O, we get the position vector A bar, and if we go through the point O to point A, we get the position vector negative A bar. Okay, that means when we change the direction in our position vector, it gives a negative sign there. Okay, so we write negative of OA. Okay, so understood how I have written negative of OA, AO as a negative of OA? Because when we change the direction in our vector, so we get the negative value there. Okay, so if AO can be written as negative of OA. Okay, so similarly OB can keep as it is. Okay, OB keep as it is. So PO can be written as negative of OP. Okay, PO can be written as negative of OP. This one is a n into under bracket OP minus OA, m into OB minus OP. Okay, so put their value OP, OA, OB, OP. Okay, so what we will get here next? Now see that n keep as it is. OP value for OP here O to P. Okay, we get the P bar. Okay, OP here P bar. So position vector P bar, it represent the line segment OP. Again OA, so what is the value for OA, which is a negative of A bar? Okay, which is equal to m times OB minus OP. So OB, which is here B bar, minus OP, OP here A bar minus A bar. Okay, so this one is the value which I found here, n into P bar minus A bar, m into B bar minus A bar. Okay, so what we do, multiply this n and m under bracket, so we'll get the n into P bar minus n into A bar, which is equal to m into B bar minus m into A bar. Okay, take the term, all term together at one side. Okay, so we want the ma plus nb upon m plus n. So focus what we want here. Okay, so what we do, take n m terms together. Okay, so n into P bar, n into P bar. Okay, so take the n into A bar, n into P bar minus n into A bar. Okay, is equal to m into P bar minus m into A bar. Okay, so those are the possible term here to take the common. So take them here. So n P bar minus n A bar, n B bar minus m A bar. Okay, so m B bar, take it here. So we will get n P bar minus m into B bar. Okay, n A bar minus m A bar. Okay, n A bar minus m A bar. I can write this one. Okay. Okay, so what we do, take the A bar common, n minus m. Okay, and take P bar into B bar. We cannot take anything common from here. Okay, so we have to write adjust this term here also. Okay, OP. Okay, so OP, which is a P bar. Okay, so OB, OP, OP, P bar. So P bar it is there. Okay, so we have done something wrong here. N into OP, which is a P bar, minus OA bar, which is the A bar. Okay, OB bar, OB bar, which is a B bar, and OP bar, which is a P bar here. Okay, so which is a P bar. I have written wrong position vertices. That's why we are not getting next step here. Okay, I have to write this step again because one negative vertex is not defined over here. Okay, so this one is a P bar. Okay, what is the P bar? Because OP, vector OP, it represent a P bar. Okay, now you will get the required answer. Okay, yes. Now what we do in our next step, multiply n P bar, take that m P bar plus m P bar here. Okay, n P bar plus m P bar. So which is equal to n A bar, it is here positive n A bar, and after that positive m B bar here. Okay, this one is our next value. So take P bar common from here. Okay, so we get the n A bar plus m B bar upon m plus n. Okay, this one is our section formula for internal division. Okay, I'm expecting that you all have understood this section formula for internal division. Okay, nothing is difficult here. We just have to apply some of the basic concept here.